Can you hear me?
Yes.
Okay. I think this is the first time meeting face to face, and you're the first person, so thank you for the support. Yeah. Okay.
Yeah. Same here. How are you?
I'm good. We'll just wait a few minutes for others to join. Hi, Natalia.
Hello.
So let me start by sharing my screen while others join. Screen. Can you see my screen?
Yes.
Okay. So yeah, so we'll just get started, right? And people will join along the way. So I've already started recording. And this recording will be published on YouTube and we'll share it in the community and also on LinkedIn and Twitter, right? So, yeah, so welcome everyone to the second, I think this is the second Sovereign DBaaS Community Call. So today, right, as you can see from the slides, right, so we're going to compare deploying and managing PostgreSQL on managed services like AWS, Aurora, Azure, right, and other managed services. Right, these are, I would say, are the biggest, and we can all agree on that, right? So using just compute instances, right, still provided by these cloud service providers, right? EC2 for AWS and Azure VMs. So yeah, I think most of you, if you're already in the community, you already know me by now. My name is Divine Odazie. I'm a technology evangelist at Several Nines, and I manage the Sovereign DBaaS community, right? I have experience in engineering and do stuff with Kubernetes and data on Kubernetes, and also experience as a solutions architect with AWS. So let's get started. So what will be the agenda? So we'll start this conversation by looking at, okay, why do organizations use managed DBaaS, right? Then we look at deployment, doing a comparison between managed and like using the just compute instances. Then we look at day-to operations like observability and monitoring. And one of the critical aspects that's being talked about is high availability, right? And the reason why they choose these services and scalability. And look at the long-term cost on a high level, then a Q&A, and then we'll call it an end. And the estimated time we plan for this call is 1 hour, but we may very well go beyond that. So let's get started. So first of all, right, I don't know if this is you. If raise your hand if anyone here has used, or if you're listening later on, if you have used deployed the database with Aurora or any managed services, right? I know most of the listeners, both current listeners and future listeners, may have done so, right? And would also have some experience deploying on a self-hosted service, right? But yeah, this is a user that is using a Reddit user that's made a post, right? Looking to migrate from RDS, Amazon RDS to self-hosted Progress, right? And if you've ever used some of these services, right, a lot of people have shared their concerns. They felt trapped, and this Reddit user is trapped, and we all know why, right? From the post, right, and also from experience, vendor locking, surprise storage bills, and limited flexibility, right? Their challenge now, as they want to move to self-hosted Postgres, is they need to find a solution that gives them that performance, right? That flexibility, performance, scalability that these managed services give them, right? And also the most important in data security. And we'll start this talk by looking at why organizations, as I've mentioned, use the managed DBaaS. Then we'll look at how this Reddit user can go self-hosted and still get that experience and still get that seamless experience. So why do organizations use a managed DBaaS? So there are two major reasons why organizations use a managed DBaaS. The first one is ease of setup. Right? So point and click, you go to the Aurora website, AWS web console, right? You sign up and it's pretty seamless, right? Provision, you don't have to worry about provisioning infrastructure, right? So AWS automatically provision the servers for you, gives you configuration options, like minimal configuration options. So we'll also show you in this presentation, right, in this call, you can just select either easy create or like have more configurations for AWS Aurora, right? And for Cosmos and the likes, right? So that is one of the reasons a lot of users, right? And a lot of users will still use these services, right? And the software DB installation, database is complex software. Yes, you can just install Postgres on an EC2 instance, but then again, today we need most people and most users, right? Most organizations need a cluster environment, right? And to handle replication. So setting all that up, right, is kind of like one of the reasons they use this managed DBaaS, right? And another reason is availability and scalability. So, right, high availability, right? So, cloud promises limitless scale, right? So, limitless scale, we know that it's not limited scale, but in your imagination, right? There's no limit to how you can go when using a cloud provider, especially all these big public clouds like AWS, as I mentioned, right? Also, the serverless nature and the ability to deploy multi-availability zones, multi-regions, and the two ops and the likes, right? And the likes, right? Then but then again, the challenge of managing Postgres cluster and compute instance is mostly related to the two operations, right? So it's not you can just easily, like I mentioned, install Postgres, but the two operations, that's where the challenges are, right? So handling automatic failover, point in time recovery, monitoring, that scalability, and so on, right? Just give me a second. Okay, yeah, I wanted to mute. Yes, so yeah, but then again, you can get these benefits, right, from CSPs, from these managed services on just by just using their compute instances, right? And we'll continue this call comparing Postgres or managed DBaaS like Aurora and Azure, Cosmos for Postgres, right? We self-hosting on VMs today and discussing each activity from deployment to observability and also cost, right? So we'll start with deployment. And can you get that seamless deployment like you get with Aurora that I just gave on a high level, right? Yes, you can. So deploying an Aurora, like I mentioned, right, you just go to the AWS console, click on RDS, you see Aurora Postgres compatibility, right? You select that option. You have the option to select between standard create or easy create, right? So if you select easy create, like the next setup is pretty seamless, right? You just select are you doing in a dev environment or in production environment, and some minimum configuration and set up encryption and select encryption and all, right? And you have your database cluster up and running, right? And if you want to have like a replica, you can add a replica or multi-availability zones, right? So that is pretty seamless, the ease of setup. So if you want to go to like an EC2 using an EC2 instance or self-hosting, right? You will start to think, how will I replicate this on using just VMs, whether it be on AWS, Azure, as the key focus in this talk, or DigitalOcean on any provider, right? It may seem like a challenge, like trying to do manual setup, right? But then again, a tool that we've talked about in our last community call, right? So, like cluster control helps you make this deployment, gives you that seamless experience that you get in managed DBaaS, but also the ability to deploy it on just EC2 instances or Azure VMs or any other instance provided by any provider, right? So as you can see on the slide, so you just after this cluster control installation, you click on create a database cluster, right? You select the type of database you want. In this case, Postgres, right? And the vendor that you prefer to use, right? And the version you want to deploy, and then you do the rest of your cluster configuration, right? From SSH configuration to, let's say, extensions if you want to use PG vector in your database, right? So it is possible to get that same seamless experience, right? If you don't want to manually install and worry about setting up replication and all those stuff, right, that you have to think about when you want your cluster, your database to be highly available, right? Then pros and cons, there are some pros and cons between these two, right? Aurora, right, as you gave an example, and using a vendor neutral tool like cluster control. So the pro, right, for Aurora, we can see that easy to set up, like limited scale as I talked about. Pay as you go, it stores the databases for you, right? serverless features. You can choose not to worry about like the infrastructure and use the Aurora serverless feature, right? But the con, right, which in our very first slide at the beginning of this presentation is that that's a Reddit user that shared his concern, right? Vendor locking, and also version, right? So Aurora, it's not vanilla Postgres, it's AWS version of Postgres, right? And also slow version in the aspect of version, slow version update. So let's say the latest version of Postgres is 17, right? So you don't get Postgres version 17 immediately on Aurora, right? Take some time, and let's say you want to have you want to access the newest feature, right, of Postgres, right? And also a personal experience having a conversation with someone that said, okay, you were using RDS, not Postgres in specifically, right, in a multi-tenant setup, and their clients needed to deploy PG vector, right? Well, with the multi-tenant setup, rather, with the multi-tenant setup, if they install PG vector on one tenant, it affects the rest of the tenant, right? So see that kind of challenge, and they had to like resort to using an EC2 instance and doing a whole new setup, right? So all those kind of challenges and limited instance type. If you've used Aurora before, you know that there are different three categories of instances and limited instance type, and lack of control, right, which is as a result of the vendor locking and also the manage features of these DBaaS, right? Lack of control equals to long-term cost because you're not flexible. You can't make customizations and make things to improve on your specific need, right? Then if you look at the vendor neutral setup, right, you get the same experience, right, as using a tool like cluster control, same experience as Aurora or Post Cosmos DB, right? The only con that we can look at is provisioning of infrastructure. So that is a con that a lot of people worry about provision of infrastructure, especially looking at in a clustered environment, right? But we can look at how we mitigate this con using like an infrastructure as code tooling like Terraform. So the next slide. So let's say you want to use a tool like cluster control, but you're worried about okay having to provision infrastructure, having to go to either EC2, right, AWS console and point and click and all, right, or Azure or any other provider, especially if you want to use like a mix of the three, right, a mix of two, right. You can use a tool like Terraform that is vendor neutral, also Ansible. CDK is particularly for AWS, right? If you just want EC2 instances, or Chef, right, or some other infrastructure, Pulumi, that helps you provision infrastructure as code using programming languages like Python, right? So in this example, you can see here that this particular piece of HCL, which is the code that is used to the language Terraform code is written in, right? So you can see that we use Terraform to configure the AWS provider, right? Provide variables for the SSH key pair, the SSH path for the SSH file, and also the number of the variable count for the number of instances we want, right? Then on the next image, you can see we configure an AWS security group, right? If you're familiar with AWS, you must have to deal with set security group, right? So this now example is not secured, right? Seeing that we are not using a specific range of side-out block, right? And it's just like open to all. Well, this sets up a key pair between the two instances, right? And then the next resource, you can see that the next resource launches EC2 instances using that key pair, right? And the number of instances, right? Then preset the private IP addresses for us to use in a tool like cluster control, right? And set up the database cluster. Then now you imagine going from using Terraform and then going to use a UI or no, right? DevOps engineers, we want DevOps engineers. Every engineer, most places want to do things programmatically, right? And use a single system or a single suite of systems to do things, right? Or implementing your DevOps workflow. A tool like Cluster Control also has a Terraform provider, as you can see here, that you can configure the Terraform cluster control Terraform provider, right, and set it up. Then you can also deploy a Postgres cluster, a replication cluster, right, with the Terraform provider, and you can use, like as you can see here on this image, use the IP or host name of the EC2 instances you create, right, and also the SSH key file and the key pair, and some other configurations that are like install database software. If you want cluster control to install the database software for you, you can enable that, and cluster control installs the database software for you on those EC2 instances, right? So you can see how you can mitigate that con, right, of provisioning infrastructure. Then writing, anyone can write a deployment script, can write code to the Postgres, right? But the most important thing is the two operations. That is one of the one of the considerations, right? When deploying, when choosing between my managed service or you're using self-hosting rather. So let's look at observability, right, as a start. So the term observability and monitoring, right, you must have heard, is often used interchangeably, right? But we know that the goal is to know what's happening in your system, right, in order to make business decisions, right? Not all metrics are important, right? The level of importance can vary. It depends on one scenario, but mostly it depends on business impact, right? And on this landscape, right, you can see this landscape or observability landscape comparing Aurora, right, AWS Aurora, Azure Cosmos DB, and using EC2 VMs, right, enhanced with a tool like cluster control. And you can use some other open source tooling, right, that give you some feature or all the features, right? So looking at it from metrics collection, query performance insights, alerting, dashboarding, and like visualization, and all this, right, with flexibility and customization when you use EC2 or EC2 instances or just VMs, right? Rather. So if you used Aurora before, right, you would agree that yeah, the Aurora performance insight feature like is great for general metrics, but then again, when you want more custom alerts, right? Let's say, for example, for long running query or to check for missing partitions or some other business metrics that is like SLA driven, right? You have to use it. You somewhat in most cases you have to configure CloudWatch, which is AWS native, right, with some other third party tool, maybe Datadog and all, right? So seeing that you're going to integrate another tool altogether, right? So why not go for the most flexible approach from the start, right? So that is the argument. And I also gave a talk about like simplifying database troubleshooting with cluster control, right, in a conference earlier in the year called Conf42 Observability. So you can scan this QR code if you're with your mobile devices. I will also share the slide in the community later on, where you can scan this QR code to go and watch the talk on YouTube as I go into showing cluster controls features and all, right? And next, high availability and scalability. And this is a major question, right? Like I've been reiterating that can you get that seamless high availability, scale, and manage the two operations, right? Like automatic failover, point in time recovery, like without a managed DBaaS, right? The short answer is yes, and let's look at how we can do that. So in most cases, you don't need limitless scale, right? I would say you can't afford limitless scale, right? In most cases, because like it's not you're running a business to make profit, right? And you can't just spend all the money you have because you want to or because you can, right? And so that is why you don't really need limitless scale, especially for some types of application, right? And the possibility of limitless scale can make a team, like an engineering team, like ignore some challenges or some issues they have to solve, like writing better queries, for example, that cost you to use more resources, right? So how will you achieve automatic failover on EC2 or Azure VMs or any VMs, right, when you deploy Postgres? So they're open source tools, right? We've already mentioned cluster control as a vendor neutral tool, right? So there's Patroni that helps in automatic failover, right? There's Rep MGR that's provided by a company called EDB that offers a lot of open source tools for Postgres, right? There's PG auto failover, there's stolen, and also there's the PFA, which is Postgres automatic failover, right? So next, as we continue in this presentation, we'll look at how automatic failover can be done on Patronia, right, and also on cluster control. So on a high level, right, we can look at automatic failover with Patronia. So Patronia uses STCD, right, which is a database or console to store cluster state and leader information, right? Detects the leader failure through health checks and all, and a consensus system, right, that we cannot go into deep to talk about in this presentation. Elects a new leader from a standby node, right, when there is like a failure, right, and we call the cluster to follow the new leader, right, and you can integrate like other tools like a load balancer like HA proxy, right, to provide a virtual IP address for the cluster, right, and all of that configuration you can do. So on the right hand side, you can see like a simplified logic, right? Patroni is written in Python. You can just see simplified logic of all this on text, right? As the monitors the leader, triggers the failover, right? And HA proxy providing the virtual IP, right? So the next now we'll look at is scaling, right? So scaling with Patroni. So you want to scale with Patroni, you provision the servers, install Postgres, right? Update the Patroni YAML. So I'm saying all this on a high level, right? Detects the nodes and initiate replication, right? That streams keeps the node to keep the node in sync, right? The standby node and all. So you can scale your clusters to add more nodes, right, into your Postgres cluster. Let's say you're going from a one node, two node, or three node cluster and going above, right? But then again, right, if you look at this approach, like you can see that it's manual, right, or somewhat manual, and the most important reason, the major reason people use managed services is because they don't want to do stuff manual, right? Because manual is error prone because we are humans, right, and we can make mistakes. So let's look at how we can scale with cluster control, right? So cluster control as the tool using an example in this presentation, right? You add new nodes, you can add new load balancers. Cluster control automatically does the installation of Postgres for you, right? So let's look at a scenario in a case, right? Okay, you've had a cluster running for a few months, right, or almost a year, or just a two-node cluster, and you want to make it three-node, right? But then again, when you initially created the cluster was running on there's the latest Postgres version, and it was running on a previous version, and the new node, right, you install a different Postgres version, right, and there may be version conflict with some of your queries or some of your features of your cluster, right? So that kind of issues and stuff, right? If they occur, cluster control automatically detects them, right? But in most cases, not in most cases, when you have a cluster on a certain version, cluster control will install the exact version, right, on the new nodes, replicate the data, and deploy Prometheus, like for monitoring, right? Because you need to know what's happening in your system, right? And the next part is automatic failover, which we saw how can be done while with Patronium, right? Cluster control continually monitors your database health, initiates failover if there is an error with a node, right, with the primary node that is receiving read and write, and repairs the failed node, right, and also most importantly alerts the team using cluster control, right, because you need to know what's going on. And let's say if a failure happens in the middle of the night, right, and your team is based, you have just one team and there's no one on call, right, and it happens in the middle of the night. In most cases, you wake up seeing that cluster control has done the failover and repaired the node, and that failed primary node is back running as a secondary node, right, and this minimizes downtime and ensures your data availability all the time. Then the next, right, one of the major look at backups, you can write scripts to take automatic backups, right? And backups is the most I would say, and we can agree, right? The most difficult aspect of backups, right, is achieving doing performing point in time recovery, right? And that is one of the key features of a tool like cluster control, right? Because point in time recovery is crucial for maintaining data integrity and like minimizing data loss in a database system because failures do happen, right? Some certain failures do happen, maybe accidental deletion, or let's say you had an attack, right, from hackers or something like that, right? It's so seamless with cluster control because you just click on restore backups, right? You can have scheduled backups that take up that happen on a daily basis, on a monthly basis, right? You select like the compatible backup, right? Specify the time you want to backup for the position, right? You've already looked at the backup and know when you want to recover from, right? And then you recover your database with that backup. So that is the key thing, right? That is one of the two operations that most database users are worried about when they want to use EC2 instances or use the VM, or when they want to self-host, which is the general word of that approach, right? So another key challenge or something to consider, right, is upgrades. Upgrading your database in a clustered environment, right? You need to maintain consistent software versions, right? And upgrading, imagine you have different databases, right? And each three nodes, so you have to manually go into each node and upgrade them, right? And perform all these actions. So cluster control does automatic detection, right? So you can go and check for available upgrades, right? And it lets you for available upgrade and shows you paths and different types of upgrades you can perform, like a copy upgrade or a backup and restore type of upgrade, right? In the cluster control UI, and explains to you like what happens, right? And shows you as the upgrade process goes about. And you can also do upgrades. From some organizations use private repositories, right, for databases, for their databases, right? And you can also specify the repository you want the upgrade to carry out from, right? So these are major D2 operations. These major concerns that people that want to migrate from managed service, right, to self-hosting have, right? And they always think about, how would I solve this problem? How would I, like, what will I do if there's a failure? What will I do if I need to restore a backup? Will I have to do it manually? And you can have a tool like Cluster Control or weave together open source tooling, right? And make sure that you have that peace of mind and you can sleep well through the night, right? Like major people that I talk to have that feedback. So the next aspect of this talk, right, it's the long-term cost. And you may be thinking, you must have been thinking, right? So all this, what is the cost comparison, right? Like, why would I why would I choose why would I not choose a managed DBaaS and use a tool like cluster control, right? Long-term cost is the most important thing, right? Because cost today may be cheaper using a managed DBaaS, right? But what about the cost tomorrow? Analyzing long-term costs, right? And deploying on these two approaches, right? Supported by tools like Patroni or any open source tool like PMM for monitoring, or you're using cluster control. It requires a multi-facet approach, right? You have to look at it from different sides, and seeing like this is just we're just focusing on Postgres, right? And we don't have a lot of time. We're going to talk about that more in our next community call, which will be 2 weeks time from now. But you can look at it from a high level, right? So upfront cost for managed DBaaS, you can say the upfront cost is relatively low, right? And you just select the type of instance you want, and you have your database running. You don't have to worry about provisioning infrastructure and all that, right? For self-hosting, you can say it's medium to high, right? But then again, it depends on the size of your deployment. So you can get, as a new AWS user, or let's say you can get the minimum AWS instance, right? So I think you can get an instance for like $24, right? And you can use a tool like Cluster Control, Cluster Control that offers a community version that is free, right? So, and you'll be up and running in no time for the similar or less cost than a managed service, right? And the model with managed DBaaS is the pay as you go model, and everybody enjoys, right? And with self-hosting, using a tool like cluster control, you can have that pay as you go model, right? Which does not tie you in, and you have that flexibility that you desire, right? And custom optimization with flexible plans on managed DBaaS, but self-hosting, uh, you have that flexibility, right, to manage costs. Let's say if EC2 instance today, right, are getting more expensive. I'm Nigerian, right, and we have several local cloud providers in Nigeria, right? I can start using some of those providers in Nigeria, right? And if most of my users are in Nigeria, right, and you can be as flexible as possible in order to optimize costs. So on a high level, we can say like the total cost of ownership, right, for a managed DBaaS is lower for small deployments, and for self-hosting is lower for mid to large deployments, right? And but then again, seeing your deployments would most likely grow, right? Because let's say you're a startup or you're an existing company that is planning to launch a new product, right? And you already have a customer base that will use the product, right? Which approach will you take from the onset in order to have that flexibility and optimize costs? And like I mentioned, right, in our next call, we'll go deep and analyze like the long-term costs from different sides, right, on using a managed DBaaS also and also self-hosting with tools like cluster control. In wrapping up, choosing between a managed DBaaS solution like AWS, Aurora, Cosmos DB for Postgres, or self-hosting, it's dependent on the organization, like your specific needs, right? Like we saw from the earlier first slide, right? They had a concern with cost, escalating cost, default setup, limited flexibility, right? So it depends on your needs, right? Managed DBaaS offers setup and limitless scale, right, but can lead to vendor lock-in. Self-hosted provide greater control. Self-hosting, you have greater control and more flexibility, like we've seen, right? And tools like Cluster Control can simplify this process in self-hosting. Whether you want to self-host on-prem, right? You want to self-host on the cloud, or you want to have a multi-cloud environment, or you want to have a hybrid environment using on-premises infrastructure and also being on the cloud, right? And I've come to the end of this presentation. And if anyone here has any question, this is an interactive session, Q&A, right? So you can ask a question and just can turn on your mic, turn on your video and ask a question if you have any. And if you're watching this presentation, right, and this community call later on in the future, you can also drop your questions on YouTube, right, or in the community, and someone will answer you. In most cases, I'll be the one answering you, and you can learn and we can learn from each other. So I can see, yeah, I can see a question from Arvind. I'm sorry if I'm not pronouncing your name well. So Patroni works on-prem, but do we use on cloud? So yeah, you can also use Patroni on the cloud, right? You can use Patroni on any operating system, right? Because Patroni is open source. I'll just go and get the link for Patroni, GitHub Patroni. So Patroni like is a templating engine, right, for Postgres, highly available to Postgres, and also works on Kubernetes, right? So both on Kubernetes on-prem, right, and which is a different topic entirely, right? And yeah, so I don't know if that answers your question.
Yes, yes. Thanks for
Yeah, thank you. So we'll just wait if there's anyone that has any other question.
Hi, Divine. Thank you for facilitating this.
So, seeing that there's no any other question, so I will just go to the next slide. So, if you want to learn more, whether you're watching this later on or you're in the community, right, you can always message me on Slack, Divine. You would definitely see my name on the SDBaaS community channel. And to join the Slack workspace, you can just scan this QR code, right? And we have a page on LinkedIn where we share a lot of resources and content, and you can follow that page on LinkedIn. And you can always email me. I always say that I reply to emails very fast, right? Because I'm always online. So you can always email me, and I'll get back to you like in a few minutes or less, right? So thank you very much for taking your time to watch this talk. If you're watching later on and for taking your time to be live here on this session if you're currently watching now and for the question. So yeah, we've come to the end of this presentation and I've stopped recording now. Okay, I see another question. Okay, from Carl. Say, where can I find more information on the cost differences between RDS and EC2 instances? So there are a lot of information online, right? And is a pretty like I mentioned, right? There are different approaches to it, right? There's a lot of information online. If you go on Reddit, you see a lot of conversations that do some analysis, right? And also at several nights we've prepared some resources on that which we'll share, and I'm also preparing a presentation on that in the next community call, where we'll dive deep into that, analyzing the cost from different angles, both on scaling and backups and all, right, when deploying on RDS or EC2 instance. So I don't know if that helps with your question, Carl. Okay, yeah. So just wait a few more minutes in case anyone has more question, then yeah. While I wait, let me see if I can get some info, some links to share on the chat regarding cost of RDS and EC2. Self-hosting with EC2. So I just sent the link on, yeah, the Reddit post that I highlighted on the first slide. I'll just go back to that post on one of the very first slides, and you can see. You can see, yeah, so some of the replies from people, right, on the post they talk about like the cost and all, right? And with that, let me go back to the slide for the community to join the community so anyone that haven't seen it can scan. And with that, we've come to the end of this session, and we have more sessions planned, right? Like I've mentioned, the next call regarding the long-term cost of using managed DBaaS versus self-hosting on EC2, right? Or any other instances on maybe Azure VMs or DigitalOcean, right? We have more community calls planned, and we'll be talking more about as the community name is, right, Sovereign DBaaS, right, and we also have community members come and present their experience, right, on working in the real world and on real world problems and that require them to have a Sovereign DBaaS, right. And next year will be a great year, hopefully, as we have more community members come and present and discuss, and we'll have more live sessions, AMAs, which are Ask Me Anythings, and presentation. So thank you all for your time, and do have a great Thursday. And I can just say you do have a great weekend. Yeah.
Thank you.